Hi, my name is Emily, and I'm reporting to you from Secret Lab at AADL. So this March, we're reading The Sirens of Mars by Sarah Stewart Johnson as part of the SciFri book club. And March is also Women's History Month. So what better way to celebrate than to learn about the amazing accomplishments of women in astronomy? So joining us today, we have Lindsay Zrull, who is Curator of Astronomical Photographs at the Harvard Observatory. And she's going to tell us about some women in the latter half of the 19th century and early 20th century who made amazing discoveries in astronomy, even if they weren't recognized for it during their time.
Hi, my name is Lindsay Zrull, and I am the Curator of Astronomical Photographs at the Harvard-Smithsonian Center for Astrophysics. And today I'm going to talk to you about the women who worked at the Harvard Observatory between 1875 and 1950. So to start us off, I thought I would talk about my favorite of these women. Her name was Wilhelmina Fleming. And in 1893, she sent a speech to be read to the Chicago World's Fair titled "A Field for Women's Work in Astronomy." And in this speech, she said, "A great many women of today must have a similar aptitude and taste for astronomy, and if granted similar opportunities, would undoubtedly devote themselves to the work with the same untiring zeal." She then went on to explain the work that she and 12 other female colleagues were doing at the Harvard Observatory. So who were these women? This was a team of women all working at Harvard Observatory before women were even allowed to study at Harvard. Right, so collectively, they were known as the Women Computers, and this is a photograph of them from 1891. That's Wilhelmina Fleming standing at center because she was their supervisor. Over to the left, you'll notice a man standing there, and that is Edward Pickering. He was the director of the Harvard Observatory at the time, and he's there because, well, first off, he hired all of these women to work at the observatory, but also he was an advocate for women in higher education and women in the sciences, which might sound a little funny to us today because we're used to women being able to go to college and study science or work in laboratories. You can really do any of these things today, but back in these days in the 1890s, it was highly unusual. And I just want to point out the term women computers, right? Because nowadays we're used to computers being laptops, desktops, even your cell phone is a computer. But back in these days, computers were humans who crunched numbers and did calculations for scientific work. So because this group of women was so unusual, they were quite famous. Here are just a small portion of newspaper articles about these women between the 1890s and the 1910s. You can read some of these are very interesting, like "Woman Scientist at Harvard Has Amazed Astronomers by Discovery of New Star." There's a lot to unpack there. The fact that you had to put the word woman in front of scientist is one interesting thing. And the fact that astronomers back then were automatically assumed to be men, even though we had this whole team of women doing this work at an observatory. There are many, many newspaper articles about these women, as I said. But I would like to take a moment just to pause and look at some of these images that you can see in front of you. So there is a photograph of a telescope here on this page over on the right, but most of the imagery that we're seeing of women working, they're all working at desks, using paper notebooks and even looking at these little squares. Those squares are actually photographs of the night sky. You might be thinking, that's odd. Why are women studying photographs of the night sky instead of using telescopes? And that's because in this era, it was mostly men who did work at night with telescopes. Partially, that was because people thought that it was inappropriate for women to be up all hours of the night using telescopes with other men. But in actuality, using photographs of the night sky was really some of the best scientific technology of the time. And let me explain a little bit to you why. So these photographs, they were called glass plate photographs. So basically you just had a piece of glass, like from your window, and on one side of it is a very thin, dried solution that is light sensitive. The men working at night would take these glass plates, put them underneath a telescope, and your telescope would act as a camera. So you would have starlight coming through the lens of your telescope and imprinting on your little piece of glass. Why is this the best technology of the day, right? That is because when you look at a star, or when you look at the sky through your telescope, your eye can see what it can see, but a photograph can actually pick up more images from the sky than your eye can. And that's because if you have a long exposure on your glass plate, that is, you keep your plate underneath the telescope for even up to 2 or even 3 hours, that light-sensitive emulsion will start to collect light from fainter and fainter stars. So in effect, these women were able to see more of the sky than anyone had ever been able to see before. So I'm talking about photography in the 1800s. I know you're thinking black and white, which is true, but you might be thinking of an image like on the left or on the right? You have the black background, white dots, because that's what you see when you look up at the sky. But these were all negatives, which means those were reversed. So the image on the left is more like what these women were looking at for glass plate photography. So every little black dot is a star. And just so you know, these are mirror images. These photographs are mirror images of each other. This is the Large Magellanic Cloud, which is very important for the work that these women were doing. And I'll get into that in a little bit. So because these women could see more of the sky than anyone had ever been before, these plates were ripe for discovering new objects. One such discovery came from our friend Wilhelmina Fleming in 1888 using this exact plate. So if any of you are familiar with astronomy, you might have some astronomy buffs in the audience, you know the Horsehead Nebula. It is photographed a lot. It is very beautiful. But in 1888, this is the first time anyone had ever seen it. And this is what it looked like. So we're talking about a nebula. And on this plate on the right, in the center, you'll see it dark, wisps could have clustered in the middle there. That is a nebula, but that is Orion. It's not the one we're talking about. We're looking in this little red square, which I've enlarged on the left. And you can sort of see a little wisp, almost looks like smoke. When we get closer, this is what we can see, right? The image on the left is from 1888 and the image on the right is from 2016. Some of you are now seeing this image from 2016 and saying, yes, I've definitely seen the Horsehead Nebula before. It's just really interesting to think in 1888, this technology enabled someone to see it for the very, very first time. So a little bit about Wilhelmina Fleming. She came to the US, to Boston, from Scotland, along with her husband in 1879. And she started working as a housekeeper for Edward Pickering, the director at the time. For whatever reason, we don't really know the details, her husband disappeared and she was pregnant. Edward Pickering and his wife realized how smart Wilhelmina Fleming was. So Pickering made a deal with her. He helped her go back to Scotland to have her baby with her family. And he said if she wanted to come back, he would give her a job properly doing science. So guess what happened? Wilhelmina Fleming did come back 2 years later, and she learned how to read the glass plates and do astronomical work, and eventually became everybody's boss. So a few things to know about Wilhelmina Fleming before we move on to other women. She developed an early stellars classification scheme, which I will get into in a minute. She discovered many objects, including 59 nebulae, 10 novae, 310 variable stars, and even the very first white dwarf star. She also was the first woman to be given a Harvard Corporation appointment. So basically a title, and that title was the Curator of Astronomical Photographs. And why is that important, right? Just at Harvard, who cares? It's important because for many, many years, women had been working at Harvard, but they haven't been really put on the same level as men. So their names were not listed in the course catalogs alongside all of the male directors and the lecturers, even the astronomers. This was the first time in 1899 that happened. And on the right, I just wanted to give you a little snapshot of what it looked like to work at the Harvard Observatory at this time. So these wooden cabinets are actually holding glass plate photographs, and each glass plate photograph has its own little paper sleeve, and you can see that in the doors that are open. In 1895, I would guess there was less than 10,000 glass plates in this collection. They'd been collecting since about 1885, but nowadays we have over 500,000 because they kept collecting them until about 1992. Our space looks much different nowadays. So another type of work that these women were doing at Harvard Observatory was studying stellar spectra. I know you're looking at these images and thinking, those do not look anything like any stars you've seen before. And that's because spectra are taken in a very different kind of way. So basically, when you'd put your plate underneath your telescope, you would actually put a prism in front of your lens. So I'm sure most of you have held up a prism to the sunlight before and seen a rainbow pattern come across your carpet. It's essentially what's going on here. So these would look like little tiny rainbows if this wasn't black and white photography. But it's okay because they didn't really need the rainbow colors for this work. What they were looking at, if you look at these horizontal smudges, as you can see, this is a whole star field on the left. Each one has vertical lines running through it. And you can see it a little bit better on the one that I blew up for you on the right. These lines, different on every star, astronomers knew probably meant something, right? They just didn't know what. Because why would stars have all of these different patterns if they didn't mean anything? So a lot of the women who were working at the Harvard Observatory at the time were looking at these stellar spectra images and trying to organize these stars based on the different patterns that they were finding and coming up with classification schemes, basically doing just that. One of these women was Annie Jump Cannon. She was well loved at the Harvard Observatory. She worked there from 1896 all the way until 1940. She actually became the second Curator of Astronomical Photographs. And here are some photographs of her. She went to Wellesley College, which was an all-women's college at the time, and then transferred over to Radcliffe, which was considered the sister school to Harvard. So women couldn't attend Harvard, but they could attend Radcliffe, which was the sister school. And there she studied astronomy. And from that point on, she started working at the Harvard Observatory. And one thing to note, though, about her that's really important is the fact that after she graduated from Wellesley, she got sick, most likely scarlet fever, and she lost much of her hearing. So she was almost entirely deaf. That did not stop her from doing incredibly important work. Some of her contributions include the stellar classification scheme that she came up, right? All of those spectra that we were looking at, she organized stars based on those absorption lines that she was seeing running through them. And it turns out that the organization she was doing was directly correlated to how hot a star is. They didn't know that at first, but now they know that. And this stellar classification scheme that she made is actually still used today. But why is it important to know, that these are organized by how hot they are? It's because today we know that stars go through life cycles. They get hot, they get cool, they change color, they get big and small, just depending upon where they are in their life cycle. And this was really the beginnings of starting to understand that about stars. So the foundation of astrophysics today largely rests on work by women like Annie Jump Cannon. Another type of work that was very popular at the Harvard Observatory for these women was measuring variable stars. So the glass plate I'm showing you on the right, that is an object in the Southern Hemisphere called the Small Magellanic Cloud. We saw the Large Magellanic Cloud earlier. They're both visible in the Southern Hemisphere. And you'll notice all of these markings all over the glass plate. And they're pointing at stars with giving them little letters. Basically, a variable star is a star that is changing in brightness over time for one reason or another. Sometimes they change in brightness over a couple of days. Sometimes they change in brightness over years or even centuries. But this particular type of work that these women were doing, we're looking at Cepheid variables, which are stars at a very particular point in their life cycle where they've become unstable. And they are fluctuating in brightness over just a couple of days to a couple of weeks. And that's important because when you're taking photographs night after night after night, what you could do was take a photograph from Monday and compare it to a photograph from Saturday, and you can actually see the changes happening rather quickly. So once you have found your stars that are changing and given them letter designations, you would write in your notebook a column of letters, as you can see, and then a column of numbers. And those numbers represent how bright that star is on that particular plate from that particular night. And this would take a long time, right? Because you want to look at that same star over weeks and possibly even months of time to see how long that star takes to go from dim to bright to dim again. And this is the work that Henrietta Leavitt did. As you can see, this is her notebook there. And she even drew a pattern of the stars that she was interested in for this particular project that she was working on. So Henrietta Leavitt published her findings in 1908 and 1912, studying specifically the Cepheid variables in large and small Magellanic clouds. And you can probably read on these titles that she found over 1,777 of these variable stars just in these two regions alone. And in her publication, she wrote, the brighter the star in these areas, the longer it takes for them to go from dim to bright to dim again. And it didn't take long for astronomers to realize that that was a very vital bit of information. And I'll get to that in a second. So who's Henrietta Swan Leavitt? We don't actually know that much about her. And that's because she was a very private person. She was very quiet. She worked at the Harvard Observatory starting in 1895. She didn't leave any journals. She didn't leave any letters or scrapbooks, unlike Annie Jump Cannon, who left boxes and boxes of things. So we know a lot about her for that reason. Henrietta Leavitt, we know about her from her work. And we also know that when she was studying at Radcliffe, she was already deaf, just like Annie Jump Cannon. So Annie Jump Cannon was not the only woman who was working and with the glass plates and was deaf at that time. So let's talk about her contributions really quick. Her study of Cepheid variables led to what was now called the Leavitt law. At the time, it was called the period luminosity relationship. Essentially, the brighter the star, the longer the period, the longer it takes to do those fluctuations. And it turns out that was the essential information for creating a yardstick for measuring distances in space. She also discovered 2,000 variable stars, which is important, but not as important as this yardstick we're talking about. Just to give you an idea of how important this information is, we now know that we are not one galaxy, but billions of galaxies because of this discovery. So other astronomers took the Leavitt law and used it to start measuring how far away things are in space. Most importantly would be Edwin Hubble. Many of you probably familiar with Hubble. He saw a Cepheid variable in what was then thought to be a nebula called Andromeda. And he measured how far away that Cepheid was thanks to the Leavitt law. And he realized things in space are much, much further away than they originally thought. So much more far away that there's no way that Andromeda was a nebula swirling gas and dust like the Horsehead Nebula, but rather it is an entire collection of stars very far away. And that was the beginning of us understanding galaxies. Which brings me to our next work, counting galaxies. In the 1920s and the 1940s, women weren't really looking at variable stars anymore or even stellar spectra. They were instead looking for galaxies. And I just want to point out on the bottom right, this is the paper envelope that goes with this plate we're looking at. You'll notice Neb A and Neb, old nebulae, new nebulae. That's because they were still calling them nebulas, essentially. They hadn't quite started calling them galaxies yet in 1934. But what we're looking at on this glass plate is Andromeda, which we now know is a galaxy. Right in the middle, you see that smudge, and that is with all the red markings. That is Andromeda, but all of the little purple marks, the little arrows, and the little numbers next to them, those are suspected to be galaxies. And the way these women did it was actually quite simple. They would look at these plates, go inch by inch over them, looking at every single point, every single little black dot, essentially. And the way they would decide if it was a star versus a galaxy was if it was a sharp point, it was probably a star. But if it was fuzzy in any way at all, it was probably a whole collection of stars very far away. So you can see on this glass plate alone based on the notes at the bottom right, that the person who was using this plate, Muriel Mussells, counted over 458 new suspected galaxies. Another person who did this work was Adelaide Ames. This is a photo of her here. She was very interested in galaxies, which makes sense because she was at the Harvard Observatory in the 1920s to 1932, and that was the hot thing to study at the time. She actually worked with the director of the observatory at the time. His name was Harlow Shapley, and together they published a survey of all of these bright galaxies that they were finding in the sky. And her big discovery was the fact that galaxies are not evenly distributed throughout space. So since people started to realize what galaxies were, they kind of thought, if you look over to the right in the sky and then to the left, there should be about the same amount of galaxies spread out evenly. But that's not the case. It turns out galaxies are clustered, and it depends where you're looking in the sky to know how many you're going to find. The last woman I'm going to talk to you about today from the Harvard Observatory was Cecilia Payne-Gaposchkin. She's also quite famous, like Cannon. She came to the Harvard Observatory in the 1920s. She originally was in England, but she wanted to study astronomy. And it turns out all of the universities there told her, you're a woman, you're not going to be able to become an astronomer. But she knew about this team of women who were working at the Harvard Observatory. So she wrote to the director at the time, Harlow Shapley, and asked for a place among them. And lucky her, her wish was granted. So she arrived at Harvard, and she wanted to do a very different type of work. And I'm going to show you, this will look familiar now. You've seen stellar spectra. So you know that Wilhelmina Fleming and Wilhelmina Fleming and Annie Cannon were working with spectra, but they were organizing and classifying stars based on how hot they are and the absorption lines. That's not what Cecilia Payne wanted to do. She wanted to look at these absorption lines and use a background in physics and chemistry, as well as astronomy, to try and figure out what do these other lines mean, right? Not just how hot the star is, but what else can we figure out from these absorption lines? It turns out you can find out an awful lot about a star based on these pattern of lines. So she was the first woman to get a PhD at Harvard in astronomy. Not just the first woman, the first person. They basically created the program for her based on her research. So in her thesis, which was called Stellar Atmospheres in 1925, she said she could figure out the chemical composition of a star based on these lines. And the most remarkable thing was that there was over 1 million times more hydrogen in a star than is prevalent on Earth, which is pretty wild, right? 1 million times is a lot. So other big astronomers at the time read her thesis, and they were kind of like, that seems a little out there. I'm not so sure, Cecilia. So they did their own research. Most notably, Russell, who worked over at Princeton, then wrote a publication that said, okay, yeah, she's right. You can figure out the chemical composition of a star based on looking at the spectra. And yes, there is 1 million times more hydrogen in a star than is prevalent on Earth. But why is this important to us today? We know that stars are big, hot, gassy things in the sky, right? So star 101, we all know this. But this is when we first found that out. Stars are burning up this hydrogen, and they are big and bright and hot. And thanks to Cecilia Payne-Gaposchkin, we know that. Aside from her remarkable and groundbreaking work in astronomy, Cecilia Payne-Gaposchkin was also the first woman to be promoted to a tenured professorship at Harvard. And then later she became the chair of the astronomy department, which also made her the first woman to lead a department at Harvard. So we've talked about some really amazing women who worked at the observatory between 1875 and 1950s. But we didn't really talk about what it was like to be working at the observatory in that time, besides the fact that women could work there, but they couldn't study there. So I just chose a date sort of in the middle, circa 1900. What was it like? Women were paid really low wages, usually about 25 cents an hour. If you were very special and very good at your work, like Henrietta Leavitt was, she was given 30 cents an hour. The only woman at this time who had a salary was Wilhelmina Fleming, who was paid $1,500 per year. And she didn't think that that was a whole lot, especially considering that the male assistants who just starting out at the observatory were paid over $1,000 more than her. So in her journal in the year 1900, she wrote that she approached Edward Pickering, who was her director at the time, to say just that. You know, she does so much work. She works overtime. She works nights, weekends. She deserves, better pay. And she was told that she receives a very good salary as far as women were concerned. And that may have been true because women were paid very little back then. But that certainly doesn't make it fair. And it took a long time for women in astronomy to start seeing equal wages. And today, some people are still fighting for that, unfortunately. These women were also nominated for awards, prestigious awards. Pickering would nominate Fleming. I believe Cannon was nominated for several awards, but in the early years, they were rarely eligible to win. So a nomination is great, but winning wasn't possible just because they were women. They had little to no access to telescopes is another thing that some of the women thought wasn't great. I have a photo on the right of Annie Cannon at a telescope in 1922. She was the only woman of this early cohort that we know of who was allowed to use telescopes. So she worked at nighttime with a telescope and during the day using the glass plate photographs. And just so you know, the reason she was looking at a telescope in Peru is because she visited one of our satellite observatories. So Harvard had observatories pretty much all around the world, both hemispheres, to take these images. Because if you want a collection of the world, of the sky as is seen from the world, you need to take photographs in the north and in the south. So she went to go visit the site in Peru in 1922. But she was really the only one until maybe the 19-teens that got to use telescopes. This was also often viewed, the work they were doing on glass plates was often seen as sort of, menial work. It's repetitive. It's not as, flashy as the stuff that astronomers were doing at night. But this was actually, as we saw, very important work. These women were making groundbreaking discoveries using glass plate photographs during the daytime. It was also physically and mentally extremely stressful work. Several of the women had struggles with their eyesight over time from squinting at these tiny dots. Even Wilhelmina Fleming wrote that she saw a physical therapist every week for her shoulder for stress injuries. And mentally stressful work too. Wilhelmina Fleming also noted in her journals that she basically got sick from being overtired, from overwork. And she knew it was coming for a long time, but she just kept working until she just broke down. Other women, such as Antonia Mori, had anxiety, severe anxiety over her work. And another woman was even written about as having these, what they were calling fits of hysteria back in those days, right? Nowadays, we would call that panic attacks or anxiety attacks. But at work, she would just, have an anxiety attack and have to be sent home. And this happened to her many times. So it was not easy work, not even in the slightest. Another thing to note that there was little opportunity for advancement, even if these women were working so many hours and doing such difficult work. Wilhelmina Fleming was the only woman to get an official appointment, which I mentioned earlier was in 1899. There wasn't another one until 1938, and that was Annie Cannon and also Cecilia Payne-Gaposchkin at the same time. Sounds pretty bleak, but there was actually a long wait list of women who wanted to work at the Harvard Observatory during this era. And that's because these women were going to women's colleges, learning the sciences, learning about astronomy, and then they would graduate and want to work. But there was nowhere for them to work except for the Harvard Observatory. A few other observatories around the country hired one or two women here and there, but not consistently. So it was very difficult for these women to find employment in the sciences back in this time. So much so that many of the women who were graduating from these schools were offering to work for free just to have the opportunity to study astronomy. So I have been working at the Harvard Observatory for 8 years, and I look at these glass plates every single day. Here's an example of one of the paper envelopes that has a plate in it. And I started to notice that there are a lot of names written on these notes, right? Names and initials all over. This particular plate has writing from Henrietta Leavitt and Wilhelmina Fleming on it. And I decided I only knew about a couple of these women, so why not make a list, right? So that's what I started doing, making a list of initials and names, recording the dates and the types of work that these women appeared to be doing. It was not easy work. As you can see from this plate, the handwriting is often very hard to read. Also, if you just have an initial and you never have a name to go with it, it's hard to fully identify somebody. There were inconsistent staff documents. Many people who used the plates didn't even leave marks on paper envelopes, so there was nothing to go by. Women changed names. There were a lot of struggles, but at the end, I was able to find over 200 names that I could positively identify as women working at the Harvard Observatory using these glass plates. So these women were astronomers, volunteers, computers, assistants, students. I didn't make any distinction based on their work. I didn't leave anyone out, basically. And that's because I truly believe that the work of someone's life, like their astronomy, their passion for astronomy, shouldn't be weighed in wages, right? A lot of these women didn't even have the opportunity to get paid. So this list of over 200 women, they're really remarkable, not only because of the great discoveries they made, which were important, but also because they helped pave a way for women today, right? We always want to go back to this question of why does it matter? These women matter, even though they were invisible for almost a century. They matter because today women can go to college and study astronomy. Women can work at a Harvard Observatory or any observatory for that matter. And they can get paid to do it. But back in these days, these women really had to break through that glass ceiling to make that possible. And I truly believe we need to recognize the work of the people who came before us. So I really hope you've enjoyed this presentation. If you're interested in more information about these women, there are several publications that are out there. The Glass Universe is one of my favorites by Davis Sobel, and I'm sure the librarians at the Ann Arbor District Library would be happy to help you locate them. Thank you.